Before we begin this video, you'll need to go to Moodle and print out the Module 2 Key Graphs page so that you will have these graphs in front of you. These are several graphs that you'll need to be familiar with, and we will be using them in the next few sections and throughout the course. So make sure that you have those, and then we'll go from there. Okay, there are three graphs in these Module 2 Key Graphs that we have talked about before, but we may not have named them the same. A constant function is of the form f of x equals b, or y equals b. And we know y equal to a number is a horizontal line. So a horizontal line is known as a constant function. The identity function is the equation y equals x. And so if you look at that, we know that it is a line with a slope of 1 because the coefficient of x is 1 and the y-intercept is 0. So if you wanted to graph the identity function, you would just go through 0, 0, and you'd go up 1 and over 1, and you'd have another point, up 1 and over 1, and you'd have another point, and so on. Our third function is the linear function, which we talked about in our first module. And here's just an example of it. F of x equals mx plus b. Remember, m is the slope, and b is the y-intercept. Okay, number 4 is called the square function. And this, you'll notice, is a quadratic function with just y equals x squared. Now I want you to notice a few things about this function. First of all, it goes through the point 0, 0, because 0 squared is 0. It goes through the point 1, 1, because 1 squared is 1, and it goes through the point negative 1, 1. Now I would suggest that you go ahead and write those points on your graph because that will be helpful as we go on into our next lesson. Another point that would go through is 2, 4, because 2 squared is 4, and negative 2, 4, because negative 2 squared is 4. And of course, those go on forever. So we need to talk about the domain of this function. And we've already talked about quadratic functions because we have arrows on both sides, domain being minus infinity to infinity. The range of this function is lowest to highest. Our lowest y value is right here at 0, so our range is 0 to infinity. We also are going to talk about symmetry. Now we've talked about the axis of symmetry going through the center of the parabola or the vertex, and in this case the y-axis, if you were to think of it as a mirror, uses the y-axis as a reflection so that we can see either point on either side of the y-axis. So we have y symmetry. And when we have y symmetry, we have what's called an even function. So if you can look at a graph and see the same values on the right and the left, the same y values, but the x values opposite in sign, then we know we have y symmetry. Our fifth function is called the cubic function, and that is the equation y equals x to the third power. Now in this graph it looks like it kind of lays down on the x-axis, but it doesn't. It just approaches it. So this is a function that goes through 0, 0, it goes through 1, 1, because 1 to the third power is 1, and it goes through negative 1, 1, negative 1. It also goes through the point 2, 8, because 2 times 2 times 2 is 8, and it goes through the point negative 2, negative 8, with arrows on both ends. So we know our domain is minus infinity to infinity. Our range is minus infinity to infinity. We have no lowest and no highest point. We have no point furthest to the left and no point furthest to the right. Now this particular graph is what we call origin symmetry. And the way that you can tell if something has origin symmetry is because if you look at the coefficients of the points, the coordinates, we see that negative 2, 8 and 2, 8 are the same numbers opposite sign. Same thing with negative 1 and 1, 1, same numbers opposite sign. That tells us that we have origin symmetry. When we have origin symmetry, the points will be in either quadrants 1 and 3 or 2 and 4. If we have origin symmetry, then we have what we call an odd function. Our sixth graph is the square root function, and the square root function is y equals the square root of x, and you'll notice that x has to be greater than or equal to 0. And the reason for that is because if x were negative, we would have a negative number under the radical, and that would be imaginary. So I know that the square root of 0 is 0, so 0, 0 is on this graph. The square root of 1 is 1, so 1, 1 is on this graph. And the square root of 4 is 2, so 4, 2 is on this graph. Domain. Furthest left is 0, and it goes on to infinity. And range. Lowest to highest. The y value is 0, and it goes on to infinity. And in this particular function, there is no symmetry.